Okay, homework 5-3 is over binomial probabilities. And binomial probabilities are going to be problems that have a fixed number of trials, and the probability of each trial is the same, stays constant. So the probability stays constant for each trial. And that'll make a lot more sense as we get into these. But the first thing we're going to do is just find the mean and the standard deviation of these trials. And here are the formulas you need to know. So for the mean, it is simply the number of trials times the probability of those trials. And for the standard deviation, it is n times p times 1 minus p would be the standard deviation. So as we read through our problem here, we're talking, suppose that we decided to test Clara, who works at the psychic center, to see if she really has psychic abilities. While talking to her on the phone, we thoroughly shuffle a standard deck of 52 cards, regular cards, and draw one at random. We ask Clara to name the suit. After getting her guesses, we'll return the card to the deck, thoroughly shuffle the deck, and then pick another card. So they're doing that how many times? 16 times. We repeat this process until we've drawn 16 cards. So we're doing that 16 times to see how many she gets right. Okay? The probability, so things you got to figure out here that they don't just give you, the probability of her successfully getting one of these right is 1 out of 4. She's got, or a 13 out of 52 chance. Let's say she gets a club and it's really a club. There are 13 clubs out of those 52 cards. So she'd have a probability of success here. I'm going to write down probability of success is 1 out of 4. That's the probability of her getting it correct. The number of trials here, they're doing that 16 times. All right. So just if we were to guessing, how many should she get right, the average should be the mean, which is the number of trials times the probability of success. All right, that's going to come out to be 4. So we would expect her to get 4. That would be the mean. And then to find the standard deviation, we're going to plug these numbers in. The number of trials, probability of success, and then 1 minus the probability of success. I mean, you can use decimals here too. And then you would type that in your calculator. Let me do that real quick. So that's going to be the square root of 3, which is 1.73. Would be my standard deviation for that problem right there. All right, so the main things to remember here, these formulas, that one and that one, okay, to find the mean and the standard deviation. All right, let's look at the next problem. We're talking about binomial probabilities. So here they flat out give you probability of success is 0.35, and you have 6 trials, okay? So they tell you those right away. They want to know what's the probability that you do this experiment and you get exactly 2 successes. Okay, well, there's a formula, and here's the formula. This is your combination, the number of combinations, probability of success. And then 1 minus the probability of success. Okay, so for my problem, what I would have to do here is we got 6 trials. We're looking for exactly 2 successes, so x would be 2. Probability of success is 0.35. 1 minus 0.35 is 0.65. And that would be, what is in? 6 minus 2, this would be 4. These numbers right here, these exponents here, always add up to this one here. Okay, so I would type that in my calculator. It would give me my answer. Now, your calculator, your TI does this for you. It generates this formula. So it's got this formula stored in it, and all you have to do is type in the N, the P, and the X, and it gives you the answer for you. So let me walk you through that. So on your calculator, if you're looking on your calculator, there is a distribution button. It's actually above your variable button. So you'll see a vars button, and above it you see distribution. So you want to hit second vars and get to this menu right here. And then if you scroll down to I think the number 0, you're going to see binomial or binom PDF. Okay, so you want to go down to that, and then it's going to ask you, depending on what model you have. Let's just say you have one of the older models though, and they don't ask you for P, X, and N. This is what you're going to need to type in. It's going to be binom PDF. You will type in the number of trials, followed by the probability, followed by the number of successes. So in this case, it would be X. And so we would type in, on our calculators for this problem, I type in binom PDF. Number of successes was, or number of trials was 6. Probability of success is 0.35. And we're looking to, what's the probability of getting 2 of those? So out of 6 events, the probability of success for each event is 0.35. I don't know, what's the probability of getting exactly 2 of those? I type that in my calculator. It gives me the same thing that this is going to produce. Okay, just to make sure we're doing that right, let me do that real quick. Just to go into my calculator here. I think, there it is. Oops. So actually, yeah, on this newer calculator, it's actually, you have to go all the way down to A to get binomial PDF. So anyway, I'm going to click on that one. Number of trials is asking me is 6. Probability of success is 0.35, and my X value is 2. Type that in. I'm coming up with 0.328. Would be the probability of getting exactly 2 out of that would be 0.328. Okay, so that's PDF, because I'm just looking for exactly, the keyword here is exactly. All right, let's see how that changes in the next one. So this time we got, again, probability of success is that. Here's my number of trials, but it says what's the probability that the experiment results in more than 7 successes? Okay, so we got to think about this a second. So I'm doing 9 trials. Out of those 9 trials, I could get 0 successes, 1 success, 2 success, 3, 4, 5, 6, 7, 8, 9. So I could get all 9 of them. You know, there's a probability. I could figure out what's the probability of getting all 9, or probability of getting exactly 8, or exactly 7. And I can do that using my formula I showed you on the last slide, or go to my calculator and type those numbers in. All right, so in our case, though, you got to understand the probability. Here's the other thing you need to understand. If I could generate all of these probabilities, the one associated with each of these numbers. And if I were to get all these values right here, and if I were to add all those values up, it should equal 1, because that's a probability distribution. Okay, just something to remember. It's going to help you work this problem. But what I'm looking for is more than 7 successes. So really more than 7 would be, I want to know what probability of 8 and 9, those two added together are. Okay? So I could do those a couple of different ways. I could go to my calculator and do that binomial PDF for 8 and 9. Do it for 8 and then do it again for 9. And then just add those together. That'd be one way to do it. But I could also go to my calculator and use this thing called binomial CDF. And it would give me an answer right away if I type in the right thing. So the difference between PDF and CDF is PDF is only going to do one number. So it's going to do 8, just the probability of getting 8. This CDF does it accumulates probability. So I think of it as whatever I type in here, it's going to find that probability. Let's just say I type in the number of trials is 9. The probability of success is 0.84. And if I were to type, let's just say I were to put an 8 in there now, the difference between these two is what this is going to do is it's going to give me the probability of 8, 7, 6, 5, 4, 3, 2, 1. It's going to count down from 8. It's going to find all those probabilities and add them together. Okay? And what I want, really, I want more than 7, right? So I want these two. So how does that help me? Well, if I were to type in 7 to this right here, and let's just do it real quick. Binomial probability, I'm going to go second vars, go down to binomial CDF, which is all the way down to B on the calculator I'm looking at right now. Do the number of trials as 9, probability of success is 0.84, and if I type in a 7, it gives me this, all of this blue here would be 0.435, okay? Which means these two down here now, these two down here should be 1 minus 0.435, which would be 0.565. So these two down here, because this whole thing right here's got to add up to 1. All right, so the probability of getting 8 or 9 should be 0.565. And so if I'd have done this and found these two separately and added them together, I should get that same number. Okay, those are gonna, this is gonna take you a little, get some practice with these. This isn't, you're gonna, this is gonna be one of those that you're not gonna want to miss on the test, okay? But they're often missed because we don't pay quite enough attention to them. So CDF, think of that as counting down. CD, count down. Think of PDF as P for precisely 1, okay? This gives me just one number. This gives me, whenever I type this number in, it's going to count down from that number and add up those probabilities. All right, good luck with these, and let me help you if I can.